Hi GATE aspirants, we are live now. In this session, I'm going to talk about GATE 2022 electronics devices question. This question is based on N-channel MOSFET, okay, which is in enhancement mode MOSFET. So this question was asked for 2 marks, GATE 2022. So what is the speciality of this question? Because they are directly asking about drain to source current. I mean, what they are asking, let's see. In the question, they are asking about the maximum value of drain to source current, right? This question was asked 802. Many of you might not have been able to solve this question, right? Or you might have taken a lot of time solving this question, right? What was the reason? So let's read the problem first. Okay, this question was asked in GATE 2022 EC paper. The subject is electronic devices. Okay, that is one of the favorite subject of mine which I deal in India. Okay, and many students in fact prefer to take course from me, right? I have been guiding for electronic devices and analog circuit. So the question, this was question number 40, and consider an ideal long nMOSFET enhancement mode with gate length 10 micron. Okay, so they have given gate length, that is L, 10 micron. We can while going through the question, you keep noting whatever information is given, and the width they have given here is 100 micron. The product of electron mobility and oxide per unit capacitance, okay, oxide capacitance per unit area, COX they have given. So mu and COX they have given, some word is written, forget about that. Product of, so you know, mu n times COX is given as 1 milliampere per. The threshold voltage of the transistor they have given here is the Vt is equal to 1 volt. Now this is what the culprit here is. Okay, this makes everyone confused, okay, because they have given DC plus AC, you can say DC plus AC they have given you. Now your VGS is what? DC plus AC. So your VGS is given as 2 minus sine 2t, your gate to source voltage. And in electronic devices, we always study about when a small signal is riding on the DC signal, right? We always consider that when we talk about MOS capacitor, in fact, right? So if you have attended my class, you will understand. Okay, so VGS is equal to 2 minus sine 2t. So here we will be getting two values of VGS, you know, because we will get VGS minimum and we will get VGS maximum. There will be two value of VGS, right? Here they have given this kind of a VGS, so you have to find two values of VGS, right? You can't conclude with one values. What is VGS minimum? The VGS minimum can be obtained, you know, this is sine 2t, right? So if I draw a sine, so it looks like this, okay, from 1 to minus 1. So what we are going to do here is we are adding with minus sign 2, so it will be inverted, but it's okay. If you want to get minimum VG, what you will put here, you will get 2 minus 1, so you will get minimum VG here. And if you want to find maximum VG, so you will have to put 2 is already present and you have to put what? Minus 1 from sine 2t. This is the minimum value, but if you will put the minimum value in order to find VGS, right, VGS maximum, so it will give you 3. There are two VGS value, right? Okay, so there are options given. The option A is what you will calculate, try to calculate what the maximum value of drain to source current, okay, when VDS is also given. So they have given VDS as well. VDS is given as 1 volt, remember. Okay, So what we have to, first of all, what we have to check, in which region of operation, the very first step is what, in which region of operation our nMOSFET is working on. Okay, so we have to find the region of operation first. Then, so region of operation. Okay, according to region of operation, we have to use the current equation. Region of, first step is to investigate the region of operation. For MOSFET to turn on, for any MOSFET to turn on, here the enhancement MOSFET is there, okay, an N-channel MOSFET. So you want VGS must be greater than VT. VGS must be greater than VT, and your VT is 1. Okay, your V, so your, and VGS values are, 2, I mean VGS value is 1 and 3. So you have to consider what, VGS max, so that your transistor will turn on. First of all, VGS max is greater than VT, that is 3 greater than. So my first criterion is. Now the second one, you have to find out what, you have to find out VGS minus VT and compare with VDS. Let me write here so that you could properly check all these things. Any problem is given, first of all you have to check VGS is greater than VT. If this condition is not satisfied, means you don't have to check further conditions. You have to consider that your MOSFET is in cutoff. The moment you check VGS is greater than VT and this is satisfied, so you have to go to next check. Okay, next investigation, what you have to find VGS minus VT, and you have to decide which value of VGS you are going to pick up or use here, right? So we have to consider VGS max. So find VGS minus VT and compare with VDS. These are the very important steps. So what you can do here is, your VDS is given as 1, I guess, and your VGS minus VT. Okay, so if you will put 3 here, if you say this is VGS max minus VT, 3 minus 1 will give you 2, right? It will be 2 and it is 1. So you can say that it is going to be, your VDS will be less than VGS minus VT. If this condition is like that, okay, then you can directly say that or claim that your MOSFET is in linear region. So let me write here, if VGS is greater than VT, this is very essential, and VDS is less than VGS minus VT, MOSFET will be linear. Now you have to recall the equation for linear region. What is the drain current equation for linear region? That is ID. ID is equal to mu1 CUX W by L, okay, VGS minus VT, VDS minus VDS square by 2. So this is the equation, okay, you must know already, right? So here you have to find maximum drain current, so you have to write ID max, and you have to use VGS max here. Now you can plug all the values which you have got and you will get the answer. This is IDS, that is maximum value of drain current, drain to source current, you can say, yeah. So mu1 CUX is given as what? Mu-n CUX, right? Okay, so mu-n CUX, let me get back and check. So these are the very important condition you need to investigate, you need to check first, okay, before going to use the equation for current. Okay, so what is mu-n CUX? That is 1 milli, right? And W by L is given as 100 micro plus 10, that is 10 micro. here we can say that 1, and one more thing is there. See, in the gate examination there is no offline calculator allowed. Okay, so what you have to do here is you have to write the number part here and the exponent part separately. Why it is it has to be done so? Because in the examination there is less chance of committing silly mistakes. See, the exponent part 10 to the power something can be managed manually, and the number can be multiplied using online calculator. So always keep this in mind. See, µnCux is, this is the place where you guys make mistake, where I used to make mistake during the gate examination. Okay, keep this in mind. First of all, any MOSFET is given, you have to test, you have to investigate in which region of operation the MOSFET is working. Okay, so VGS is greater than VT, and VDS and VGS minus VT you have to compare. Okay, when it is less than VGS minus VT, overdrive voltage you can say, your MOSFET will be happily operating in linear region, and you have to use this equation. From where this equation I have got, we discuss always in the classroom. Okay, what is the importance of µnCux? What is the importance of W by L ratio and everything we discuss in the class? In fact, I will be discussing here as well, right? So ID max is equal to µnCux W by L. So µnCux is given as 1 milliampere per something. Okay, so 1 10 to the power minus 3. W by L. W is 100 micro and L is 10. So you can say 10 only. So if there is a 10, what is 10 to the power 1? That is 1. So plus 1 you can add here. Don't write 10 here, because after 10 is when plus 1, right? Yeah. Now what you can do here is, now VGS minus VT. What is VGS max? That is 3 minus 1. What is VDS? That is 1 minus 1 by 2. Very simple. So further you can go ahead. So W by L was, let me check again, that was 100 by not 10, so it is simple. You can solve this. I think this will be 2 minus 1 by 2. 2 minus by 2. So this, okay, I think this is easy without using calculator. In fact, you can do within one line, and this will be 10 raised to power minus 2. Further, if you will solve, so it is going to be 4 minus 1 by 2, 3 by 2. You can say that 1.5 to 10 raised to power minus 2, or you can say that 15 milliampere. Okay, so what you have to do, whenever any MOSFET question is given from the devices and they are asking about the current, what you have to do, test VGS is greater than VT or not. If VGS is less than VT, stop everything, answer will be 0. Okay, so answer for this question is what? Answer for this question is C. Okay, so let me write the equation for C. So number one case is what? If VGS is less than VT, stop, your ID will be 0, and this is known as cutoff region. Your MOSFET is in cutoff. If VGS is greater than VT, VGS is greater than VT, then what you can do? Check further. You will be having two conditions, right? You have to calculate what? You have to calculate VGS minus VT first. So once this step, okay, which is VGS is greater than VT is cleared off, right? So you have to find what here, the VGS minus VT. You can say that you will get VDS is less than VGS minus VT, or VDS is greater than or equal to VGS minus. This is what? This is the linear operation. Okay, I mean your MOSFET is working in linear region. not linear operation, it is in linear region, and this is known as saturation. This is what I want to tell you extra. Now, in case of linear region, you have seen what will be the current equation, and in saturation region, where the your MOSFET behaves like an amplifier. Okay, for the MOSFET to behave like an amplifier, you have to work on saturation region. So your ID is going to be what? Your ID will be always equal to 1 by 2 mu n cox W by L, aspect ratio VGS minus VT. I hope this is clear for everyone. When your drain to source voltage is less compared to VGS minus VT, that is in what? That is in linear region. And if your VDS is further increased, so that would, your MOSFET will be driven toward saturation, and where MOSFET behaves like an amplifier. I hope this concept is clear. We'll meet in the next session with new question. Thank you.